the idea of muonic catalysis. Namely, it is believed that overcoming the Coulomb barrier of repulsion of positively charged nuclei occurs due to their attraction to a compact mass of negative.
Here is a variant of an ionized hydrogen molecule with a muon in a circular orbit. Due to the large mass of the muon, the radius of the orbit and the distance between the protons are orders of magnitude smaller than the atomic scale. This can lead to a convergence of the protons sufficient for the exchange of pions. Thus, the question arises, is it possible to create compact massive negative charges that ensure the convergence of nuclei? The affirmative answer is contained in hadron mechanics, which takes into account the contact interaction between particles of
The mechanism of nuclear convergence, generalizing the ideology of muon catalysis, is proposed in 1.2.
The figure is taken from the monograph of the creator of hadron mechanics Ruggero Maria Santilli. The overlap of wave packets of two electrons with opposite spins is schematically represented. The interval of mass estimates, 0.05 to 0.5, of bound electron, E pairs corresponds to the interval of distances, 10 to the 14 th power, 10 to the 15 th power, m between the center. A simplified schematic symbol for the CR4 activator and the symmetrical model is introduced here. Simplified view of the asymmetric scheme of approaching nuclei in the presence of a CRN activator and the condition for N. The condition for the nuclei to come closer together can be represented as quantities Q1, 2 are given in units of elementary charge, Q1. Important limiting cases. 1. Transition to a symmetrical model. 2. Attachment of a proton to a nucleus with any large charge. Therefore, the presence of the CR1 activator, N equals 1, initiates the reaction of the simplest syn. Examples of the synthesis of massive nuclei with the capture of E pairs. Obviously, this reaction leads to the same result as the quasi-neutron concept. However, it should be more efficient. When considering the examples, please note that in the first two reactions, in order to fulfill the law of conservation of electric charge, as well as the conditions for the exothermicity of the reaction, 1 E pair must be captured. Whereas in the third reaction, the absorption of 3 E pair
Mass spectrum of for tungsten isotopes. The main peaks correspond to W isotopes with standard masses marked in blue. Small peaks near the main ones correspond to modified W atoms containing massive E, pairs in deep circumnuclear orbitals, partially screening the charge of the nucleus. It is clear that W and W atoms are significantly different. Conclusion 1. There is evidence in favor of the existence of massive compact E, pairs that modify the chemical properties of atoms and also form Kern activators that catalyze the reactions of cold fusion of nuclei. 2. The universality of cold fusion catalysis involving Kern activators lies in the possibility of bringing any pair of complex nuclei closer together. In particular, bringing a proton closer to any nucleus requires the participation of a simple Co1 activator. Let us recall for comparison that in hypersynthesis 8 it is assumed that one of the nuclei is first converted into a pseudonucleus with a negative charge. 3. The nature of Kern activators as real physical objects is revealed when interpreting the observed tracks of strange radiation as a consequence of the propagation of activators. 1.
We thank you for your attention.